In this tutorial video we will be learning about Deutsch Algorithm in Blueqat. We will be doing this in Google Colab. Like we did in previous video, we will start with installation of Blueqat. We can do it by using this code !pip install Blueqat. Type the code that was shown earlier in Google Colab. Then click on play button and Blueqat will be installed. Deutsch Algorithm Overview. Oracle. Let's start with the oracle that appears in this algorithm. In simple terms, it is a function that returns 0 or 1 for some input. As an example, let's consider a situation where you are buying something. If the input is a butcher, the output is 1, and if the input is not a butcher, the output is 0. Then the following situation will occur. If the value x can be brought in the butcher shop, then we will get the output as 1, or else output as 0. Using this, we can't buy a computer at the butcher shop, but we can buy beef, so we get f computer equals 0, and f beef equals 1. Such a function that outputs 0 or 1 depending on the input is called an oracle. In a quantum computer, x contains states, and it is used to extract only certain states. In other words, it is a gate that extracts only a certain state. Deutsch Algorithm. First, let's look at the algorithm that Deutsch came up with. The Deutsch algorithm is to determine the oracle of a 1-bit input that is 0 or 1. In other words, this is the situation. When x equals 0 or 1, there are 4 possible oracles. The Deutsch algorithm will determine if this f has the same value in 0 and 1 or if it is different. Consider a concrete circuit. This UF is an oracle. However, for Q0, it returns the incoming value x as it is, and for Q1 takes mod 2 of the sum of the incoming value y and f x in Q1. Mod 2 remainder divided by 2. Now let's check the state. Now add the above equation to and transform it. Looking at the first bit, we can see that the sign changes when we swap x equals 0 and x equals 1. In this situation, consider psi_2 for the 4 ways f of x above. Since f of x is applied to the first bit, f of x equals 0, then Q1 does not change. F of x equals 1, then Q1 is inverted. Therefore, if we look at the equation created by the two transformed terms, f of 0 equals f of 1, then each term is the same sign. F of 0 not equals to f of 1, then each term with a different sign. From this, f of 0 is equal to f of 1. Psi2 equals to this equation. Further multiply Q0 by the h gate. Then psi3 is. Since plus minus is irrelevant for the measurement, we know that measuring the 0th bit determines the oracle. This is the explanation of the Deutsch algorithm. Let's implement this in Blueqat. Copy the code and click on the play button. For the input and output values of f of x, 4 different oracles were considered. This time, we will implement each of the 4 ways, and the oracle will be chosen randomly by a random number. Here, using Deutsch's algorithm, we can determine the oracle with probability 1 from the measurement results. If the oracle is f of 0 equals f of 1, then all measurements are 0, 0. If the oracle is f of 0 not equals f of 1, then the measurement results are all 1, 0. Therefore the result is 0, 0. That's all for today. Thank you.